Ladies and gentlemen, a very good day to all of you. My name is Roger Hage, proudly representing the Royal Dahlman company for nearly 25 years now, currently working as a business development manager. First of all, I'd like to thank RefComm, of course, for giving us the opportunity to present our FCC flue gas filtration technology to you in this virtual event. And I trust it will give you a better idea of the possibilities that are available for the reduction of catalyst fines emissions. Just in case you do not know us, a short introduction to the Royal Dahlman company. We are a filtration equipment and technology supplier, and we are active in the world of filtration for quite a while now, since 1886. Since 2019, Dahlman is part of the Porvair Group, one of the larger fabricators of high quality, mainly sintered metal filter elements. And this is great, of course, because now in our FCC filtration systems we can implement our own in-house developed, tested and manufactured sintered metal filter media. In the refining industry, Dahlman has a serious track record in FCC filtration solutions, such as FCC cat hopper vent gas filtration, slurry oil filtration, and FCC flue gas filtration, the topic of this presentation today. Of course, everyone is aware that our environment is important to all of us. Reduction of NOx, SOx and particulates in refineries has always been an important issue, but the regulations nowadays get more and more stringent. So many refiners worldwide need to revamp their FCC regenerator off-gas systems, and even new refineries need to implement the best available technology to seriously reduce their stack emissions. So for the removal of catalyst fines from FCC flue gas, filtration can be a great solution in situations where conventional separation technology is not sufficient anymore to meet these stricter emission guidelines. When it comes to catalyst fine stack emissions in refineries, many countries require these to be lower than 50 milligrams per normal cube, or even lower, sometimes down to below 10 milligrams per normal cube. Of course, therefore it's good to know which solutions are available and proven, what are the requirements they shall comply with, and which technology is safe and reliable to operate. So the key targets for cat fines emission reduction are efficiency. It makes sense to install the best available technology, because in the near future the environmental regulations will only get more stringent. Obviously you wish to install a reliable system with low maintenance, long operational lifetime, and finally it shall be safe for personnel and environment. This picture shows a typical FCC flue gas process flow diagram, showing the reactor and the regenerator on the left side, and the possible separation and filtration solutions that can be installed to clean FCC flue gas before it finally leaves the stack. I will go through the different options that can be considered in order to remove catalyst fines from the FCC flue gas. First, it is good to know that the typical concentration of cat fines in FCC flue gas is about 200 to 400 milligrams per normal cubic meters during normal operation. However, during upset conditions, this can increase up to 10 times higher than during normal operation. So it's very important to know, especially when designing separation and filtration equipment. One of the oldest separation technologies used in refineries to remove catalyst fines is the third separator, or TSS. Before the flue gas leaves the stack, many FCC plants have a flue gas expander or power recovery unit to recover energy from the reducing flue gas pressure. Typically, regenerators are designed with multi-stage cyclones to capture and return and drain catalyst back to the fluidized bed. However, this flue gas still contains high contents of catalyst fines that can do harm to the expander. So a third separator installed upstream of this expander can protect the expander blades from erosion due to abrasive catalyst. The third separator contains cyclonic separation technology, so multiple cyclones, reducing the high amount of cat fines in the regenerator off gas significantly. In order to optimize the efficiency of the TSS, a certain underflow needs to be extracted at the bottom of the vessel. So when 100% of the flue gas is coming into the TSS, 97% is leaving the TSS, going to the power recovery unit, and average 3% of the gas is going to the FSS, the force separator. The volumetric flow rate of the underflow gas is determined by means of the critical flow nozzle. So while the majority of the clean gas coming from the TSS goes to the waste heat or a CO boiler, the underflow gas containing all the collected fines needs to be handled as well. So in the end, this gas is united again with the gas coming from the TSS before it enters the waste heat boiler. Some refineries use a cyclonic separation device as a force separator, as you can see in this picture. The main problem is that the efficiency of a cyclone is rather low, and a lot of fines will end up in the flue gas again, resulting in high stack emissions. A possible solution for refineries already having a TSS system with a cyclonic type FSS is replacing the underflow cyclone with a force filter, because a filter has a much higher efficiency. So the purpose of the force filter is to effectively remove most of the catalyst fines from the underflow gas, and in this way assist the third separator to reduce the overall stack emission. In general, refineries having a TSS package with a FSS cyclone report fines emissions in the stack that are not lower than 60 milligrams per normal cubic meter, many actually much higher, and where a new FSS filter can reduce this to below 50 milligram per normal cubic meter, which currently in many countries is still an acceptable level. Since the force separator filter is operated at a pressure of typically 2 to 3 bar G and at high temperatures up to 500 to 600 degrees C, there are of course some critical design criteria. First of all, the filter media shall be resistant against a high temperature, and they shall be suitable to operate in the very corrosive, oxidative and dust-laden environment. Secondly, the design of the filter is very important. Due to the high solids load, the filter elements shall be optimally protected against the abrasive characteristics of the catalyst. Finally, the operation procedure and controls shall make sure that the filter can be operated without unplanned stops for at least one turnaround period. Dahlman has supplied multiple force separator filter systems which are successfully in operation for a long time. One of the reasons for that is that we apply sintered metal fiber filter media in order to achieve surface filtration and to prevent clogging, so penetration of particles inside the filter medium. They also show perfect in situ cleaning performance at low pressure drop. And although they are exposed to challenging process conditions, they have excellent lifetimes, even up to nearly 10 years. Dahlman has developed a very successful inlet device that prevents the filter media from direct impact of the abrasive catalyst fines. Since the filter elements are automatically regenerated during operation, it is critical to achieve low velocities inside the filter housing to make sure that the fine catalyst particles fall down into the cone of the filter after cleaning. Too high velocities, of course, will result in re-entrainment of fines back onto the filter elements, which will result in high differential pressure and in the end plugging of the filter. Finally, as mentioned before, the filter shall be designed to function properly even during the worst case scenario. So during upset conditions. During startup and shutdown, the temperature control is also very important to prevent condensation, and the operation of the filter package as a part of the overall flue gas cleaning system shall be safe and reliable. And yes, as you can see on these pictures, bad filter designs can result in serious problems, such as filter element failure, and even the pressure vessel can be damaged due to condensation, as you can see in the picture on the right. However, when all critical design criteria are taken well into consideration, it is very well possible to operate the system very reliably and achieve lifetimes of the filter elements up to nearly 10 years. Another possible solution that can be installed upstream of the waste heat boiler is a full flow filter that replaces the TSS and the forces separator. So in fact it is handling 100% of the FCC flue gas. The filtration technology that can be used in this location is similar to the forces separator, so typically sintered metal filter media, and obviously this will result also in a very high emission reduction. The main issue here is that due to the high temperature, the high pressure and the high actual gas flow, this option is extremely expensive. And when it shall replace the existing equipment, often also the large plot space that is required is problematic. So yes, some high temperature full flow filters are in operation in the field currently, but really only in very small refineries. Other flue gas cleaning solutions are installed downstream the waste heat boiler or the CO boiler, as you can see here on the right. These options are usually considered in refineries that do not have a TSS or have a TSS that just cannot achieve the required emission level anymore. Some refineries also consider other technologies because they have safety issues, mostly with ESPs that operate at high current and high voltage. Or they just need to comply with the new, more stringent governmental regulations. In general, there are 3 technologies that can be installed at this location. So downstream the waste heat boiler, the ESP, which uses separation technology to effectively remove catalyst fines, the wet scrubber, typically not installed for fines removal, but for SOx reduction. However, the water will catch fines too. And the full flow filter that can achieve a very high efficiency when it comes to solids reduction. When comparing all these different technologies, there are some important differences that I wish to highlight. I won't go through them all. For instance, both the full flow filter options, they're very efficient, but there's a big difference in investment costs. The filter installed behind the boiler is much cheaper and also less riskful due to the lower operating temperature and pressure. Apart from that, the guaranteed efficiency of a full flow filter is the lowest of all. Even 10 milligrams per normal cube may be well below the required emission level, but for sure it is future-proof since emission regulations will only go down. Another benefit of a filter compared to, for instance, a separator like an ESP is that it is not sensitive to solid load fluctuations. And last but not least, ESPs may cause a safety issue. The ESP is an effective and widely used technology, but it is operated at a high current and high voltage. And even though the ESP may be a common applied and reliable system, external circumstances can make the ESP a dangerous piece of equipment. As you can see on this sheet, an example of an accident that happened several years ago. Due to the benefits of the full flow filter installed behind the boiler, I will use a reference project that was installed in one of the European refineries in order to give some more details about this. This refiner had an old boiler and an ESP that was bypassed for years due to malfunctioning. So there was actually a big yellow-orange plume coming out of the stack. The new system should make sure that the emission is reduced to below 30 milligrams per normal cube for now, but also should be able to meet below 10 milligrams per normal cube to be prepared for the future, as I mentioned before, but without a lot of modifications to the system that I wanted to install now. For this customer, the choice was a new and better ESP or a full flow filter. There was no need for SOx reduction, so wet scrubber was no option for them. Now, well, this is actually a summary of the main considerations that I made when comparing both technologies. I already mentioned some of them, but actually the installed costs of the ESP and the guaranteed efficiency of the filter were the key drivers for the refiner to install a full flow filter. A filter system installed at this location shall at least comply with the following conditions. Of course, the filter media shall be suitable for operation in an FCC flue gas environment. The operation shall be, of course, well above the asset dew point at all times to prevent condensation issues. And an optimal inlet gas distribution system is required. In this specific project, also the low guaranteed emission level was an important key driver for the customer to decide to install a filter. Here you can see the general layout of the full flow filter system. Actually, it's split in two main parts, one on each side of the inlet and the outlet ducts. The inlet duct is here, and the outlet duct is just above the inlet ducting to save space. And as you can see on the picture of the inlet header, it's a special inlet distribution device that has been developed specifically for this application to make sure that the catalyst fines are pre-separated and that the gas is equally distributed inside the filter compartments. Both compartments contain filter bags. They are fabricated of a unique filter material developed specifically for FCC flue gas filtration. Now, one of the key features of this filter system is that individual sections can be offline cleaned. So the flow rate in one section can be blocked, while the other sections continue the filtration process. So in this way, the very fine catalyst particles can optimally settle down in the bottom section of the filter after regeneration. Now, as you can see on this CFD analysis, it clearly shows how the velocities in the filter housing are reduced to a very low value. The dark blue area is actually the area where the filter bags are installed. So they are optimally protected against the abrasive catalyst impact. Now, this specific first full flow FCC flue gas filter is running for almost 7 years now, currently still reducing the catalyst emission level to 5 up to 7 milligrams per normal cube, which is actually an excellent achievement. And during the first turnaround, the filter bags were replaced with new ones as a precaution. The filter materials were subjected to a serious investigation. Now, apart from the fact that there was some dust remaining on the outer surface of the filter elements, there was no sign of wear, and the mechanical properties were actually very, very good. So in fact, based on the results, it could be easily concluded that the filter bags would have been able to run for at least 6 years before change-out. So to summarize, the key features and the benefits of the full flow filter: it's the best available technology when it comes to emission reduction, cat fines emission reduction. It is safe to operate. The installed costs are low compared to other technologies. And due to the flexibility of the bag house design, it can be easily adjusted to the available plot space. Well, to conclude this presentation, I hope I gave you a little more insight in the available flue gas cleaning solutions and the role that filtration can play in the reduction of catalyst fine stack emissions, upstream and downstream of the boiler. Obviously, if you have questions or need more information, please contact us. We're most willing to provide you with advice or additional support. I thank you all for your attention, and I hope we can meet soon in the near future. Please take care.